So today I will continue from where I stopped yesterday. Remember the topic, metals and their compounds, and we are on aluminium. Yesterday I tried to describe the first part of extraction of aluminium, which is purification of the bauxite to form alumina. Today I will describe the second part, which is the electrolysis of the alumina. In the electrolysis, alumina plus molten cryolite will form our electrolyte. So make sure you give me a follow if you are new to this page and subscribe to my YouTube channel. So let's go. So the diagram you are seeing is the electrolytic tank or electrolytic setup for the electrolysis of alumina to form aluminium. So let's go. This particular cylinder is called iron cylinder or steel cylinder. It is lined in the inside wall with graphite cathode, carbon cathode. This carbon cathode is acting as negative electrode. Is negatively charged. In fact, negatively charged electrode is called cathode. Now, the molten substance inside, or the liquid, the solution inside, is the electrolyte. The electrolyte is our alumina in solution with cryolite. The three rods dipped inside this electrolyte are also graphite, but this time around graphite anode. You can see they are positively charged. These positively charged rods are connected with wire. You can see the positive charge there. The negatively charged rod also is connected with a wire, and these two terminals are connected to the terminals of the battery, maintained at 6 volts. And remember the temperature of this system. Note, the temperature of this system is maintained at 1000 degrees Celsius. Now, the chemistry of the reaction. The chemistry. Electrolyte. This time around, the active ingredients of the electrolyte is alumina. That is our focus. Al2O3. Okay. Now, ionization. The alumina will ionize into 2 moles of aluminium ion and 3 moles of oxygen ion. These are the 2 ions that will be participating. When current is connected, what happens? The cations migrate to the cathode. And the anions migrate to the anode. Why? Cations are positively charged. This time around, aluminium ion. They migrate to negatively charged carbon rod, which is cathode. Why the anion, oxygen ion, migrate to positively charged carbon rod, which is the anode. So, let's describe what happens at the cathode. At the cathode, the positively charged positively charged ion, which is aluminium ion, will pick 3 electrons. Since positive charge means it is electron hungry, it will pick 3 electrons from the cathode to form elemental aluminium. This is reduction process. This is reduction because the oxidation state of aluminium here is +3, while here is elemental aluminium 0. So this is reduction. Reduction takes place at the cathode. Now at the anode, that is here at the anode, the negatively charged part of the electrolyte, which is oxygen ion, will migrate to the anode to donate, because negative charge means electron rich, to donate 2 electrons to the anode to be reduced as atom of oxygen. Oxygen cannot exist in atomic form. Therefore, one atom of oxygen will combine with another atom of oxygen to form a diatom, which is oxygen gas. Note that this oxygen gas causes a waste of graphite anode, because it will quickly react with the carbon in the graphite and burn off the carbon as carbon 4 oxide. This constitutes a waste, and that is why the graphite anodes must be replaced as you use this electrolytic tank from time to time. Now, at the end of the day, this is the consequence. The consequence at the anode is that some carbon atoms are burnt off as carbon 4 oxide. At the cathode, aluminium that is formed at the cathode, will settle down here, and through a pipe-like path, it will be collected as pure aluminium, which is used by the industry. I hope you got value. If you did, just click on the plus sign, give me a follow, comment and share.